So our next topic is layer 2 security. And I think what I want to do is do my demo first and why do we use these things. And we've seen the term port security in a couple of the presentations earlier. And the reason port security is because layer 2 security is port security. I want to go in here and be sure that I don't have it enabled and I don't show port security, nothing's happening. Let's say that you're the network administrator. Could be, and I'll say at a university, could be at a business, and when I say student, could be one of the bosses, could be a lot of different individuals. You have your devices connected to your network. You know that you have an antivirus software on them. You know your antivirus is up to date. You know that antivirus has been scanned. The devices have been scanned for viruses. You know that all of the updates have been installed and that you're in a pretty reasonable security posture. But one day a student walks in or a boss walks in and brings their laptop. I don't want to use your machine today. I want to use my computer. So they go in and they plug their computer into your network. You now got a device on your network you don't know anything about. Has it got a Trojan? Has it got a virus? Is it about to infect you? Are there some back doors available on it that hackers can now get into your network? So what layer 2 security is going to do is to prevent that from happening. I want to plug my machine back in. Hopefully see what happens with these things. So what we want to do is make our network more secure at port security, using port security. And it's a pretty straightforward process in order to configure it. The first thing that I have to do is turn it on. Enable, and I'll go to config T. It is an interface configuration. So I'm going to go to interface range. I'm going to do all of them at the same time. Fast Ethernet 0, 1. I'm not going to do it on the gig ports. 2, 24. And let's do switch port security. And I should get an error on this. Hey, it's a dynamic. You can't configure it on a dynamic port, and by default all the ports are dynamic ports. We have to either go in and tell it to be an access port or a trunk port. So I'm going to do switch port mode access to change all of these from dynamic ports, which are by default auto in the fixed or the absolute, the auto and desirable configuration, auto and desirable being the dynamic parts of these things. So now I should be able to turn port security on. Now that I have it, I want to do the configuration, switch port security. We can configure aging here, port security aging, how long, the MAC address, and we're talking about MAC addresses here. The maximum number of addresses that can be attached to this port, the MAC address that's on the port, and what the violation is, what's going to happen if we exceed the parameters that we've set up. So let's go in here. The first thing let's do is the MAC address. Actually, let's do the number first. Let's do the maximum. The maximum, the number 1 to 132. A lot of them can be there. If we have a trunk port, we may need to have that many. I'm going to put 1 in, which is, by the way, is the default. And then switch port security. It is first we say, why can't we just do this before? First we have to activate port security with a switch port security command. Then we can go in and do the configurations that we're doing right now. And let's do the MAC address, MAC, switch port security, MAC address, and then the options here, the HHH 48-bit MAC address means we can type it in. If you like typing or copying and pasting, probably typing, you can type them in. I don't like that. We have sticky is the other possibility here. And we're going to look at sticky. What sticky does is automatically detects the MAC address and then makes it a static address. The default here, which we don't see, is the dynamic addressing that we're used to, where the switch will detect the MAC address based on the source MAC as it comes into the port, put it in the MAC address table, and we'll time out, although when we do port security we're going to disable the timeouts. The timeout default is going to be 5 minutes, 300 seconds for these things. So sticky is going to detect these things, going to put it in the configuration mode. We'll look at that here in just a minute. The sticky, we do this, and then it says, hey, we can type it in. We can configure if we're going to have multiples. We only have one on this one, so if we configured it as static, that'd be the only one that's allowed. I'm just going to use sticky for this one, and then switch port, port security, and then if we have a violation, what's going to happen? We have three possibilities here. It says protect, restrict, and shut down. Protect, security violation, protect mode. Restrict, security violation, restrict mode. Shut down, security violation, shut down mode. Protect just drops the frames. If we have a violation, too many, wrong MAC address, whatever else that we have on it, and we go into the violation mode, protect will drop the frames that come into the port. So we have that. Restrict going to do the same thing as protect, except it will then be able to send us an SNMP trap or a syslog trap. An SNMP trap is what we would look at. Shutdown puts it into what's called Err-Disable mode. It's the one I like because I can see the LEDs change on the switch, and no traffic is going to be able to go. So I'm going to use shutdown, which is again going to be the default for these things. So now I can do a show port security, and it says, hey, port security is enabled. The maximum secure addresses on each of these interfaces is 1. The maximum secure address is 1 that is permitted by port security. The current address count, how many are there? I haven't detected anything yet. Security violation, and then the security action. This doesn't mean the port shut down. This is going to be the action if we have a security violation on it. Again, I like the shutdown because I can see what goes on with it. So let us go in and see if we can get some MAC addresses on this thing. And I think probably the easiest way to do that is to ping the broadcast address. Let's try 255 and just ping. I guess ping in front of that would work better, huh? Ping 192. So we're now getting traffic that is going back and forth. We got a couple of replies here, the 50 and the 52. So I want to go in to this, and let's show the MAC address table. Show MAC address table. I now have the answers on some of the ports. This one over here is still dynamic. This is on the gig port. I didn't put port security on it. Notice that the ones that I configured port security on say static. So fast Ethernet 01, 02, 03, and 04 have addresses available. Well, I only allowed one per. Show port security. When I look at it, we now have the count. This one, apparently only one of these guys answered. I think this one is 52. So since I only am allowing ping 192.168.1.52, and let's see what happens here. Yeah, that's what would happen when we try to put that second MAC address on the interface, because we only allowed one. It puts it into Err-Disable mode. And let's look at it. Show port security. It says that here on fast Ethernet 04 we have a violation. We got one MAC address because that's all that's allowed on it. We try to put a second one on, you're done. You can't get there because we don't allow that. Let's show interface fast Ethernet 04. When we look at it, the status here is down, line protocol is down, it's in Err-Disable mode. I can fix that by allowing more addresses. Big T interface, fast Ethernet 04. So we'll go switch port security maximum, and let's say 3 just for the heck of it. So I can now have 3 addresses on this one. Let's try to do a no shut. This should work, right? A no shut, it goes to down. That's what Err-Disable does. In order to bring an Err-Disable port back up, we got to what's called bounce the interface. Do a shut and then a no shut when we do that. Now it is up, and now we should be able to go in here and do this ping without making a mess out of things. So yeah, we're doing that. It worked here, and the reason that it worked is because we're on the hub. Remember, a hub sends the information out all the ports except the port it came in on. So it sent it to the switch, and the switch said, hey, that MAC address is there. You've just created a violation situation. The other thing I want to do now is go here and do a show run. What does Sticky do? It puts the MAC address in the running configuration file. You'll notice these other guys don't have anything on them, but actually I did the whole thing. Let's go to the gig port down here. The gig port, nothing shows up on it. And no configuration shows up on it. Probably because we didn't configure it, huh? We could do that. What I really wanted to show is, and actually we could do the maximum. That's what it is. The maximum numbers here. We had maximum of 1 on everything except, and I got to get back down to it in my show run. Here we have a maximum of 3. You notice that it doesn't show up here. The maximum 1 doesn't show up here because it's the default. In the Cisco iOS, whatever the default configurations are won't show in the running config. We can see we now have the 2 MAC addresses on this port. So we can have more depending on what we have with the maximum. Sticky here, quick and dirty way to get the MAC addresses in. To make them static, I can now copy the running config, copy run start, so that they're in the startup config file. Something happens, power failure, or somebody unplugs the switch or whatever else. When it reloads, we're going to have these MAC addresses associated with those ports. Now my student or my boss comes in and says, I want to use my own device today. And he hooks it up to the fast Ethernet 03, and we're in Err-Disable mode. I don't have to go and try to smack them. I can go back and smack them after the error happens. You'd be surprised how many people do this. It prevented the students, and what we would get is the faculty would bring their computers in and plug them in, bring their laptop in. I want to use it, and then their mom, they're not going to, because they don't really know that they've done that, although it's general knowledge that we have port security enabled on these devices so that we can keep our network protected. But it is one of the methods to add to the security. If I put my guy back on here, it's not going to come up because my guy, I'm in Err-Disable mode. I've got to go to that interface, bounce the interface. 3, and I'm going to do a shut and a no shut in order to bring that interface back up. There is an auto recovery mode that you can configure, and we'll talk about it in just a minute. Demo here. Let's go ahead and take a break and come back, and then we'll go through the slides. Although it looks like we didn't get off the title slide, I think that we have discussed or seen or demonstrated most of what we're going to do here. A couple of terms that we'll do. Port security is the big one here. Secure MAC addresses are those that go into the port security secured ports. DHCP snooping we'll look at. It's a pretty basic concept, which is to prevent rogue DHCP servers from getting on our network. ARP Inspection is going to be used to prevent the man-in-the-middle attacks using the ARP reply message to do those things. And it's going to be related very closely to DHCP snooping. We'll look at those in a little bit. Those are pretty straightforward once we get the port security stuff done. So port security, Things that we did: allows restriction of the number of devices that can be connected to the switch interfaces. How many? The number that we have. Uses the source MAC address of the Ethernet frames to identify the devices. Port security: no restrictions on whether the frame came from a local device or was forwarded to other switches. That's, I guess, one of the maybe bugaboos, or not really bugaboos, but something that you have to pay attention to. But opinion is that, if I have port security enabled on all of my switches and I've got the correct IP addresses on all of my switches, I really shouldn't have to worry about the trunk ports. And that's what that's saying, is that no restrictions on where it came from. Did it come from me, or did it come from another switch? Is it on a trunk port? Easily, and we're going to have a limited number, depends on the switch, how many ports can be assigned to any, how many devices, how many MAC addresses can be on an individual port. And remember that the MAC address tables have a limited size, maybe a real big limit, but it has a limited size, and that's why. Here we have the things that we did: switch port security maximum. The first thing that isn't in this set is, the first thing we have to do is turn it on with the switch port security command. Then we can configure. This is an interface. We did a range. You can do an individual interface, or you can do a range of interfaces, however you want to do it. I used to work with a guy that made his classes do everything one interface at a time. Figured it was, by the time you got done, not only would you be fed up with it, but you would understand the command. I kind of like using the range. Repetitious work, what we want to do is automation in order to take care of that Defines which frames to filter using the three basic methods: the specific MAC address, and we can use either the dynamic, the static, or the sticky. They can be allowed to send and receive frames, discards frames to or from other MAC addresses, depending on how many we have in there. We can have 1, we can have 2, we can have 130 MAC addresses. Limit the number, how many can be connected, and the specific MAC address was the one where we connected the laptop and it shut. The number was when we did it initially, and we only allowed 1, and the hub had 2 devices connected to it. Try to put 2 MAC addresses on the interface that allowed 1, put it into Err-Disable mode, because we had configured it as a shutdown mode for what's going to happen if we have a violation. Discards frames to and from MAC addresses that are learned after the maximum is reached. So this is this is something to remember. After the maximum is reached, it discards these frames. A combination of the 2 methods, switch port security maximum interface configuration, allows the configuration of the maximum number, and the combination of 2 methods. We did a combination of the methods. We had the maximum number as well as the explicit MAC addresses using the sticky command that were allowed on the ports. Normally support 3 types of MAC addresses: the manually configured, we type it in; stored in the address table, added to the running configuration file; remain until manually removed or the configuration is changed to a layer 3 interface. If it's a layer 3 switch, and in order to make it a layer 3 interface, we go in and do the no switch port command on it. It now can have an IP address. It becomes a routable interface. The MAC address restrictions are going to go away. Port security restrictions are going to go away because it's a layer 2. Incidentally, if we bring it back to a layer 2 switch port, all those configurations will come back. They're still there. They're just not applied because once we make it a layer 3 interface, not layer 2 anymore. It's not going to work. The dynamic secure MAC addresses, dynamically learned, stored only in the address table, and they're dropped when the age limit is reached. And we're going to have a summary here in a little bit. That's true. But when we enable port security, that configuration disables aging on the MAC address table, on the dynamic. If they are still dynamic, they're dropped when the age limit is reached. Not persistent, and this is going to be the case. They're not going to to survive a restart of the device. Can be converted to sticky MAC addresses, switchboard port security MAC address sticky command to do these things. Manually configured, we type them in. They're part of the running config file. In both of these, the sticky as well as the statics, in order to survive a reload, we've got to do a copy run start. We've got to copy the running configuration file into the startup configuration file in order for these things. Types of the sticky MAC address, the one that we configured, dynamically learned or manually configured, stored in the address table, and added to the running configuration file. They're lost on the reload unless we store them in VRAM using the copy run start or the write command. Stored in VRAM, and this says but not displayed in the running config file. They are going to be displayed in the running config file as long as they are there. When disabled, when the static or the sticky is disabled, they're going to be converted to the dynamic secure, and the secure addresses are going to be the trusted addresses, the ones that we. So what can be done with these things, the static in the running config file can be saved to NVRAM. All of them are going to be in the MAC address table, and all of them can be saved to NVRAM except the dynamic. The dynamic are in fact dynamic, just like we configured every other time, or we had every other time, all the other things that we've had in our MAC address table. This thing, the switch mode access, port security, the things that we did, except I didn't type them in because you'd never get there if I did that. The MAC address sticky, you have to be, if you're typing them in, please be very careful about what you do with these things. Guidelines for it's got to be a static access port or a static trunk port. Demonstrated that first off when I gave the switch port access, switch port security command, and it came back and said that it rejected the command because it's a dynamic port. We had to give it the switch port mode access, or we could have given it a switch port mode trunk command. They were all access ports, so we did that. Dynamic port secure is automatically enabled on voice. An IP phone, and this is up to, and we had this one earlier, so we'll talk about port security later, up to 2 addresses. When we configure this, we have to account for the MAC address of the IP phone. And the other consideration is the IP phone may actually be detected. The MAC address may be detected on both of the VLANs, both the voice VLAN and those things. So it's just something to be aware of that you got to pay attention. If you have an issue, then you go back in and say, okay, I need to reconfigure this to allow for the MAC addresses for these things. Cannot use a secure port as a destination for a span. A span is a switch port analyzer. Fancy name for port mirroring. Fancy name for let me sniff a port that I can't see. So what we would have here, we have multiple ports here. What we can do, a couple of machines out here that we would have, and we'll connect them to a port here, connect each of them to a port. What a span port does, switch port analyzer does, is sniff. What I can do is configure, this is me with my sniffer on it, with my Wireshark on it, and this is bad guy, suspect employee. We think something bad's going on here, or we just want to watch certain traffic. So what I can do is configure span. Session is the command, so we configure a span port, and this is going to be the destination, and this will be the source. So anything that happens on this port gets sent to, as well as its destination gets sent to this guy over here, and my Wireshark is going to record what goes on with these things. You don't have to put an IP address on this guy. He can just sit there and sniff it, and you don't get the broadcast traffic in the way that you would see on the NIC that you're doing. So we only see the traffic here, and we can configure these as the inbound or the outbound traffic, or both. We can watch what goes on to the other. So span port, also called a port mirror for these things, and we copy or send a copy of each of the frames to the destination port. It's a pretty simple configuration with a session to do that, but that like to try to do the terms that we introduced that we really hadn't talked about. So cannot use a secure port as a destination for a span port. Cannot belong to an ether channel port group. A secure port can't be a member of an ether channel port group when we do these things. Changing the maximum secure addresses, and we did that. A new value greater than the existing value, which is what we had. It just took it immediately, no problem. And this says a new value lower than the existing value will be rejected. A new value lower than the existing value and the number of MAC addresses that are on that port will be rejected. We can lower the number, but if we have 5, our maximum is 5, and we have 5 addresses on it, we can't lower the number. If we have a maximum of 5 and we have 3 addresses on it, we can lower it to do those things. So we can lower it, but we can't lower it under the level that we have on the device itself. Static sticky addresses cannot be configured on a voice, and then Cisco switches do not support port security aging on sticky MAC addresses. So aging is going to be disabled. The sticky addresses are going to be there. The dynamic range, MAC addresses learn dynamically. It'll be dropped when their age limit is reached if aging is going on. Can be configured on each interface, and the range for aging 0 to 1440 minutes. 0 will disable aging, and I don't know how long that is. Anyway, the minutes here would be 3600 would be you can do the division on that. I've never actually looked at that. And the default is going to be 300 seconds. Methods when the device is receive the MAC address age. 2 different methods. One is absolute, the other one is inactivity. Inactivity, if we use that MAC address again, the timer gets reset. The absolute, after it's learned, it will then go into the countdown for these things, and that is the default aging method is going to be absolute for these things. The maximum MAC addresses default value is 1. That's why when we did the show run, we didn't see it in the configuration because the defaults don't show up in the configuration files. After we set the maximum on the port secure address, it can be added by using the switch port security MAC address interface configuration command, statically configure switch port security MAC address VLAN configuration for trunk ports. Configure a secure MAC address for a range of VLANs. Allowing the port to use the MAC addresses of the connected devices. Dynamically configure the secure MAC addresses, and then configuring some of the addresses to be static and the rest to be dynamic. You don't have to have all of them of the same type. We can put static addresses in and then still go in and have them detected if we want. Violation, the maximum we saw, the trigger, the maximum MAC addresses is reached, it triggers it. Secure MAC address is configured or learned on one secure port, attempts to access it on a different port in the same VLAN, then it's going to be an error. What the device is actually going to do is just switch the MAC address from one to the other. But this is called a MAC move violation, when we move the port, the cable from one port to the other. It's smart enough to know that, yeah, we still have these things. The violation modes we talked about: protect, disables learning when any VLAN reaches the maximum number of physical port, even if the physical port has not, the VLAN does, and then will drop the frames from the offending devices until the addresses drop below the maximum value. We don't get any notifications with it. Restrict is the same as protect, except that we're going to get restrict here. We're going to get a syslog message, yes, and then this NMP trap, yes. It's going to send us. Violation counter is also increased where it's not increased with the protect mode. Shut down, the one that we use, put it in Err-Disable mode, and it is the default. Shutdown is the default for these things. And in each of these traffic forwarders is going to be no. SNMP trap, yes for restrict and shut down. And this is if it's configured. Syslog message, yes, if configured. Error message, no for everything. The violation counter in the show port security command, violation counter is incremented, yes for restrict and yes for shutdown. Port shutdown only for the shutdown command, and shutdown error disable mode. A little different. If it's just shutdown, we can use the no shutdown. Error disable, we have to bounce the interface. Shut. Steps to configure this thing: switch port mode access, switch port mode trunk. We did that. Switch port security interface command to enable port security. The optional steps here: the switch port security maximum. We did that to show that. The violation, we did that to show that. It can override the default. We put it back in the default. It didn't really care. MAC address to predefine allowed secure MAC addresses that are going to port security MAC address if we want to specify static addresses that we're going to use. Port security sticky. And to me, again, sticky is really the way to go because you don't have to worry about my typos and they get into the configuration. Error disable, effectively they're going to be shut down. Security violation, shut down. Error disable is effectively shut down. The LED of the disabled port is going to go from green to orange or amber. A lot of times you're going to see this called amber. When we do the show interfaces command, which we did, it's going to show as error disable. The difference between it and shutdown, if it's shut, all we have to do is do the no shut. The error disable, we have to bounce the interface. And again, the change in the color of the LED is why I like it, because I can see that something has happened. Otherwise, somebody just says, I'm not going anywhere. I've got a protector just dropping the packets. I don't have a visual cue. Two main purposes: alerts the administrator to a port problem and prevents the erroring port from causing the other ports to fail. It's not going to have an impact on the other devices. Err-Disable Recovery, and we have seen that we have to go into the port and do a shut and a no shut to bounce it. We have the ability to do an auto recovery, configure an auto recovery of these things. First, we identify and correct the problem that caused the issue, and then based on the timing that's been configured, the port will repair itself. If it's re-enabled prior to fixing the root problem, it's just going to go back into the error disable state again. A lot of things that can cause the situation, and these are a listing of what goes on here: UDLD, unidirectional link detection, BPDU guard. Security violations, the one that we're interested in. Again, a lot of other things. The timer interval, 300 seconds, is going to be the repair interval. The error disable timeout interval is 300 seconds. Error disable recovery, when we do that, show this error disable recovery, we have to specify the reason that we have, that we want automatic recovery. So error disable, if error disable recovery is disabled, manually re-enabling has to be done, the shut and the no shut command. Bounce the interface. The default for port security is disabled by default. The maximum number of secure MAC addresses is 1 by default whenever it's enabled. Violation mode is shut down. Aging is disabled by default. Aging type is static. Static aging and sticky aging are disabled. You can configure, even though we say that static addresses don't time out, you can configure static aging so that a static address will time out. I guess it would be something that you would put on the device and just have it there for whatever amount, a limited amount of time for these things. We're getting to the point that we've got a couple more topics before we go to lunch, and this is DHCP snooping and dynamic ARP inspection. I think again what I want to do on the DHCP snooping is to do the demo first, and what are we trying to do? We've talked about man-in-the-middle attacks and denial of service attacks, and I've told you my experience doing my own denial of service attack with DHCP servers. This is a DHCP server that's sitting up here, and these guys should be getting DHCP addresses. Config release, and IP config renew, invalid command. IP config being one word, right? /renew. When I do this, and I'm getting an IP address. If I have the rogue DHCP server attached anywhere on the network, it's going to be giving out IP addresses. We don't want that to happen. And IP DHCP snooping or DHCP snooping is a way to prevent that. So let's go in and configure, and we'll do it one step at a time. There are two ways to configure. It can be on a per port basis, or it can be on the entire device. I'm just going to go ahead and do it. IP DHCP snooping, and then we have some information here, VLAN or whatever. This should, and we'll find out here in a second, should configure it universally. Show IP DHCP snooping. It says that switch snooping is enabled. Let's see, show switch DHCP snooping is enabled. Is configured on the following VLANs, none, which should be all of them. Well, we can go ahead and fix that in config T IP DHCP snooping VLAN. And now when we do the same show, it says the DHCP snooping is configured for VLAN 1. It's the only one that's available. What I want to do now, and this is working correctly, if this is working correctly, and I've done it a couple times because sometimes we get the works really well, and then sometimes it says, I just don't want to work right now. IP config renew with this, and it looks like it's going to DHCP request failed. What I now have is that the DHCP server ain't working. And that's what we want. But that's my DHCP server. What I want to do is prevent the rogue DHCP servers. It's on gig 01. We can fix that. So we can go into here, config T, and do interface gig 0/1, and we'll do IP DHCP snooping trust. We're going to trust that port. By default, when we enable DHCP snooping, it makes all the ports untrusted. And when all the ports become untrusted, what happens in the DHCP process is we get the discover. This is one that was on a switch, and I configured DHCP snooping on it. And you can see I get the discover. I never get the offer back. So what it does is prevents the server from sending the offer packages to me, which means that I can never get a DHCP address. Now then, let's see if we can get the address here, which is and we got it already. We had it failed, and now we've got our IP address back. The renew command here, we're getting our IP address. I want to put a new device in because sometimes what I want to show next doesn't work with the existing addresses. So let's just fast Ethernet 04. These things default to static addresses. So we'll just go in here and give him a dynamic address, and voila, he has a dynamic address. This guy should have an address. See if he has an address. Oh, he doesn't have an address. So let's do an IP config for that. He does too. Renew. He's 50. So I want to do a release and renew on him because I want to try to build a different database. Release. DHCP snooping creates a couple of databases or information bases. Show IP DHCP snooping, and then we have the question mark here, binding in database. We can do the database, and we say here we have total attempts 6, successful writes 6, so it's giving addresses out. I can see with the show IP DHCP snooping that it is enabled and it's running on VLAN 1. interfaces here, I have Fast Ethernet 0, 1, 2, and 4. These are the interfaces that have devices on them. And it says, are they trusted? No, for the ones that we have configured by default. And when we went in and configured the trust on the gig 0, 1, that now allows my server, my DHCP server, to give out addresses. Since it's now trusted, it can give that information to give the IP addresses to the devices. So I show IP, DHCP, snooping, binding, a whole big command here. This is a lot of information. We now have the MAC address, the IP address, the lease time, and the interface all here in this binding database. We need this in order to do dynamic ARP inspection. What dynamic ARP inspection is going to do is it's going to query the DHCP database here, binding, not database, the DHCP snooping bindings database, a long list of words there. And when the ARP reply comes back through this device, it's going to compare the two. So that if somebody's coming back and said that, hey, my MAC address is here, or this MAC address is my IP address, 192.168.1.1 or 1.100 or whatever else, the dynamic ARP inspection is going to say, no, it's not. And it's going to drop that particular reply, so that by combining this DHCP snooping with dynamic ARP inspection, which I have not yet learned how to configure. I don't say I can't, because I may be able to in this particular version. Have not yet learned to configure. It's going to prevent or help us, again, more help in the security aspects of the switch. And I think this is the last thing that we're going to do in the security aspects of the switch, but hopefully the things that we've done and shown here, it's like, you know, I can do a lot on a switch in order to make my network more secure. So DHCP snooping, dynamic ARP inspection. DHCP snooping, security feature that detects rogue DHCP servers and filters the DHCP traffic originating from untrusted sources. It's not going to allow it out back. What it does is doesn't allow the DHCP offer, as hopefully you saw in the Wireshark scan. We had discovers, but no responses when we did that. To do those. It acts like a firewall between untrusted hosts and the DHCP server. And when we configure DHCP snooping, it makes all of the ports untrusted. Untrusted means that obviously not trusted. An untrusted port can't give back or send the DHCP offer frame back to us. DHCP is going to be rejected on those, as you saw hopefully when we did the demo. We can implement rate limits. I didn't show that, but we could go back to, and let's go back to this guy, but go back to this guy and the switch into gig 0 and just look at, I'm not going to, we'll look at maybe what's available there. Config T, interface gig 0, 1, IP DHCP, snooping, and then we have limit. We have the trust, and the limit here is limit the rate, DHCP snooping limit rate, the rate limit, and then we configure a number here. The rate limit, how many DHCP offers are we going to be able to give? And the rate limit is to prevent users that are trying to exhaust the DHCP address space from being able to do that. So we can slow down the number that are given at any given time when we do those things. So builds and manages the DHCP snooping binding database, which I think is a really cool thing. Validates the subsequent requests. Help determine the trusted and the untrusted sources. Trusted sources are the devices under our administrative control, and the untrusted devices, beyond the firewall or the outside administrative control. In this case, spurious DHCP servers are what we're looking for. In this case, all of the ports except the ones that we say are trusted, we go in and individually configure as trusted are going to be untrusted, which means that DHCP is not going to be able to run on them. When enabled, all the ports are untrusted. Configured the desired ports as trusted, and it's enabled on a per VLAN basis. And tried to show that with the show IP DHCP snooping. It was enabled, but it was not configured on any of the VLANs. I went back and configured it on VLAN 1. Protects against bogus gateway assignments so that the rogue DHCP server can't give us a bogus DHCP address with a bogus gateway and then send all the information. DHCP binding database, dynamically built and maintained by the snooping feature, using information from the intercepted messages, contains an entry for each untrusted host. If you have a trusted host that you want to be in this database, you have to go in and manually configure it. You can add it. MAC address, least time, the things that we saw in this show IP DHCP binding, DHCP snooping binding. Updated when the switch receives certain messages, the DHCP acknowledgement from the trusted ports. And the agent enables the storage and retention of the bindings. The bindings are, the agent bindings preserved across reloads, otherwise they're going to be lost. And we really don't want that to happen because we want them to be there. Again, the bindings are for the database agent. In a couple more slides and we'll be there. Allows you to retain the bindings across the reloads. In the absence, the bindings are going to be lost if we restart the switch, reload the switch. It's going to store the bindings in a file so that when the switch is reloaded, they can be rewritten or renewed, reread into the running configuration file. Writes the file as the database changes to keep the file current, and that's what we would always want to do. Each entry in the file is tagged with a checksum, is used to validate the entries each time it's read so that somebody doesn't try to change the file. So we're going to basically create a hash, a checksum hash for each entry so that if it's changed and does the comparison, say, well, this one's not right. Let's go back and do some other things with it. Option 82 is kind of a strange, I think, strange thing that we have. The DHCP, the host of DHCP client generates a DHCP request and then broadcasts the request on the network. When we're talking about these, we're really talking about using relay agents. The switch receives the DHCP request. It'll add the option 82 information, which is basically the MAC address and the port that the device is on. And it's going to then send that information. If we got 802.1x port-based authentication, it's going to put that information too so that it enables it to get back. What we're doing here is we're using a relay agent to do these things. And the switch here, the relay agent, is going to put this information in. Switch then add the host 802.1x authenticated user identity information, the radius attributes, to the packet. And if we've configured the IP packets, of the relay agent, the switch will add the IP address of the DHCP packet, forwards the DHCP request that includes the option 82 field to the DHCP server, and then it's going to send us an address back. It's going to mirror the option 82 information so that when it comes back, the switch knows where to send it. If you look up option 82, and I encourage you to do that on Google, it just says it sends additional information to it, and it's one of the processes that allows the devices to keep. DHCP server gets the packet. If it supports option 82, it'll assign the IP address. We'll then also be able to implement policies for this thing, and then the DHCP server will echo the option 82 field with this, and then the switch will remove the option 82 information and forward the packet to the switch port that connects to the DHCP client. So additional information is the key words that go along with the option 82. Dynamic ARP Inspection, we talked about it. It's a neat thing. Defends against ARP poisoning, which can be a method of the man-in-the-middle attack. Dynamic ARP Inspection up at the top there, a security feature that validates the ARP packets contained to be a valid MAC to IP addressing. And we looked at the DHCP Snooping bindings database, and it had the IP address and the MAC address that we presume are going to be correct. That's how they got its IP address. So the switch intercepts the ARP traffic and compares the information in the DHCP Snooping database. And if they're valid, the packets go forward. If they're not valid, it's going to be dropped. But again, just basically what we said